Hi. The idea of printing houses and buildings with a 3D printer is a very fascinating and interesting idea. I have tried to collect top 10 companies that can produce housing and buildings and construct them with an innovative way and with 3D printers. It's very fascinating that more and more companies are trying to produce innovative ways to construct the buildings in a faster way, an efficient way, and cheaper way. And also, they could use biomaterial way in a way to avoid waste. And this can really help the environment and reduce the climate changes. So, in this episode, I would just look at the companies and the way that they are actually building their prototypes and just together review how efficient and also how how beautiful the architecture of these buildings are. So, yeah, let's do it together. Icon is another company that caught my eyes. Icon was founded in 2015 and it's based in Austin, Texas. The company is one of the largest construction providers using 3D printing, robotics solutions, and software. The company's numerous projects include collaborating with house builder Lennar to build a community of 100 3D printed houses, and also collaborating with NASA to simulate conditions on Mars. The partnership with the US military was recently also renewed, this time for a major project to build military bar racks. This diverse portfolio shows why Icon not only dominates the US market for its building solutions, but also plays an important role in other countries. It's also very futuristic to build houses on Mars or on the moon. It's one of the companies that has futuristic plans for 3D construction. As you see in this video, they are really working on the condition out of space and how material could react or behave in non-Earth environment, and how their 3D printing solutions could help to reconstruct or construct the uh, mm, houses or buildings in such environment. Advantage of such systems that it's unlimited, so it's just required to be put on the rails, and these rails could be extended further, and how big you can imagine this building could be printed. Of course, it does have also disadvantage because the width of the printer is also limited anyway, and but still it's a very innovative way of printing material. So the first company is called Apis Cor. Apis Cor is an American company from Melbourne in Florida that has developed a 3D printer capable of building a house in just 24 hours, even in extreme weather conditions. As for current technology, Apis Cor has a printer nicknamed Frank. This is an easy to use mobile printer that can create buildings up to 3 floors. This is an easy to use mobile printer that can create buildings up to 3 floors. It requires no additional assembly. It arrives at the construction site and is immediately ready for use. Frank has a younger brother named Gary. He is responsible for ensuring high quality of the 3D printer material. But they also have a sister, Mary, who is responsible for the supply of 3D printing material. Mary needs no bags of material, no messy hand mixing, no rain or snow. Mary is always ready to go. All you have to do is add water. Connect her to Frank and Gary for teamwork. And hallelujah. So the next company that attracted my eyes is Contour Crafting. Behroch oder Berok Koshnevis He founded this company, and he's also the professor at University of Southern California, and he has a very impressive resume in this field of technology. He has also monitored a lot of doctoral students, but the company, the idea of printing the houses was one of the first pioneers. In fact, he was one of the first pioneers in this field. But the average house in United States takes between 6 and 9 months to build. Now imagine what it would be like if a custom home could be built in just a day. Contour crafting has addressed this problem. Thanks to the advanced robotics, they can build custom homes in just a few hours. So, as you see, they have actually made a very compact machine. So, they claim that it's just one man job. It's easy to operate. You can the person or the operator can just open the arms of the machine. So it's also a Cartesian machine, but it's probably works both with hydraulic system and also electric motors for operation. So as you see, it can be easily set up on the site, and the the operator can easily handle all the required installation and calibrate the machine to the needed position. And yeah, so it can also model everything on a 3D model to see how it looks like and how the layers looks like. For example, you can see that it can set the doors or windows positions. And yeah, so everything is I'm really surprised that this was actually one of the first or pioneers companies in this field, and I didn't know at all about this company. And as I said, it's a company that is coming out of the university and a research center. So yeah, the Cartesian system works on three axes, three in fact x, y, and z axis, and yeah, it can probably print the house or building in a very short time. The next company is so-called Cobod. It's a Danish-based or Denmark-based manufacturer of 3D printed houses. Started its activity in 2017 with the construction of the first 3D printed building in Copenhagen. They are now found on all inhabited continents. The company's first 3D printer was called BOD or Building on Demand, and with it they started working across Europe, which allowed them to learn and optimize their machine. This is how they later developed the second generation of their 3D printer, the BOD 2. Recently, they released the Cobot configurator, which offers a digital version of BOD 2 printer with adjustable print head and sizes. There is even a simulation of the buildings under construction. The company's most recent projects include the first 3D printed office extension in Austria and the construction of the first two-story house in the USA. For the customers in Germany, there is a cooperation between Perry Company with Cobot, and Perry Company uses the Cobot robots to 3D print the houses. Cobot structure of the robots are Cartesian. It means that it needs to be fixed on the place on the construction site, and on the z-axis, the system just increase the height, and it just move in the x, y, and z axis to feel the way the material should be filled. So it's really important that the axis or referential positioning of the system to be fixed during the printing process. The disadvantage of Cobot printer system is that it really needs a lot of manpower to be set up on the construction site. Unlike the other one that you use a mobile platform to move the items to the construction site, um, the Cartesian 3D printers, like the one that Cobod uses, requires manpower and also crane to set up the system. So might be one disadvantage of such gantry system or Cartesian system. But from the case of precise motion, it has advantages over the Scara shape robots like the one that Apis Cor is actually using. One of the companies that actually took my eyes is a French company so-called Constructions 3D, which is a project by the company Machines 3D in collaboration with the Belgian architect Gaël Collaro. I hope that I pronounced his name correct. Leader in 3D printing with mortar. The purpose of this project is to build customizable houses from recyclable materials right on the place where you want to create the construction. So they developed their own 3D printers of the houses. Currently, they have three printers. The Maxi printer is a turnkey solution, a concrete printer that solves several problems in the construction industry. The transport of the container as well as the sturdiness of the machine resulting from its hydraulic systems. Actually, it looks like a scorpion to me, but it's really cool that it can move and it can be portable to the construction sites. But unlike the competitors, the printer itself is very fascinating. It's a mix of electric motors and also hydraulic systems. To me, it's a little bit questionable how accurate is the printer actually, but it looks like the quality of the print is not that bad. Of course, I saw some examples. There were a little bit overlaying of the layers and a little bit mess, but Cybe Construction is another company from Netherlands. Their printer is basically based on ABB robots. They have produced several printers that, according to the specific applications, can be used. One of them is a gantry or Cybe G. I would say it's like a Cartesian printer and it's fixed on the place with a specific dimension, and it just moves in a XYZ axis, and it's one of their printers. The other one, which actually attracted my eyes, is Cybe RC or Robot Crawler. They actually have made the robots to be movable with a crawler that has rubber tracks and can be moved to the construction sites, and also some hydraulic base that can move the robot or printer in z-axis for higher positions. So this was also interesting. They also use ABB robots for their robot crawler. The other one is Robot Track, which use a rail-based ABB robot. This one is also for construction, but it's also limited. The space that it can be construct is also limited. This is also downside. And the last option is just a stationary robot that moves only around its position. This is more or less for research and universities. But the most important ones is just the gantry and I think the crawler. But the crawler, I've seen it. It's actually quite nice. It can reach quite height, very high level. And the company is active, I think, from 2014 or 16. I'm not sure. And yeah, so this one is worth to take a look. I think they also have a specific pump for materials. and which they claim the speed of the printing is about 200 millimeter per second, which is quite fast. One of the downside of 3D printing material is actually, as you see in this video, um, if you want to make a hole or drill the wall, you cannot actually use the option of hammer. So it means that if there is any kind of impact on the wall, there is a possibility of a big crack in the wall, which is unlike the conventional wall, and it doesn't happen. For 3D printers, it can happen, and it can be really severe. The cracks can go completely inside and through all the wall. So this is one downside of 3D printing, and I hope that they can somehow fix this issue. The other thing is that actually drilling is not easy. The another question that strikes into my mind is that, okay, as you see in this example, the walls could be filled with materials, some materials that could like be used for insulation, heat insulation. Can this wall really tolerate the amount of force or pressure on that in a real situation? Another company that is on my list is Mighty Buildings from Oakland, California. This company is changing the industry through the use of robotics and innovative materials. The company is dedicated to two very topical issues: the availability of the housing and climate crisis. 80% of the production is automated, 60% of the materials are recycled, and the cost per house built with 3D printing is 99% lower. For the past 5 years, they have been working to make the production process waste free by developing systems, kits, and a concrete formula that reduce time, cost, and emissions. Some of the projects that have been completed in California includes a 3 bedroom, 2.5 bath home with community pool and a garage, or another 4 bedroom, 4.5 bathroom project in Caribbean. Dream homes that can be built thanks to the four technology. I think the positive side from the solution that Mighty Buildings is offering is just the, as I said, the IKEA way of putting or assembling each wall side by side, and it doesn't matter how big it is. You can order as many wall as you want and just put them side by side. It is somehow innovative, but it's time consuming. I mean, like in competition with the other competitors, it's a downside. But I think the way that they are printing is very similar to the normal 3D printers that use polymers or maybe plastic materials, fibers, something like. Of course, it's a special material that they are using, and it's basically use heating to heat up these materials, and then they cool down in the process. It seems like that the problem that we had for the others, that like a crack or impact on the wall could really damage the wall. For these materials, because they are probably kind of polymers, they are really resistant for impact or pressure, dynamic or static pressure. So this is also a positive side for their solution. Their ideology to create 3D printed houses is more or less building blocks. So it means that, like, the way of thinking of IKEA, I think you all know the IKEA, and it's like that you can assemble all these walls together, and each walls are made by specific materials. Black Buffalo 3D is a US based manufacturer of 3D printers for construction. They use durable, heavy duty cement based ink, which they claim can create structures stronger than a log wall. They are motivated to solve the growing housing crisis and reduce the construction industry's carbon footprint by using technology that allows constructions up to 4 stories high to be printed in a matter of weeks and offer cost saving of around 50%. The Nexon portal printer and range of raw materials promise to revolutionize building for the benefit of consumers. They also did quite extensive research about the materials, what type of material can be the better fit for the construction, and they try to mix different materials and fibers to find out the capability of the materials under pressure or in extreme situations. So they are not only focused on robotizing the construction, but also on the material itself. And this is a positive and advantage of this company. Also, one thing that should be considered is the temperature of the environment. I'm also curious to know how temperature could affect the quality of the cement and bottom or the material for printing, because if you are gonna to print these materials in a very hot and humid environment, it might be critical for the structure to endeavor and tolerate this temperature. Since 2012, the Italian company Wasp, or World's Advanced Saving Project, has been one of the most important manufacturers of 3D printed houses. The company works according to the principles of circular economy and sustainability. In 2021, the company entered the market with its own multi-printer crane Wasp, which produces houses in the shortest possible time using 3D printers. Their Crane Wasp 3D printer is the first modular and multi-level 3D printer ever to hit the market. It can be built in any shape in just a few days and has a print area of 50 square meter per unit. This made possible, for example, the realization of the Tech Club project together with Mario Cucinella Architects, which represents a global living space for sustainable living. In the VASP, it's the crane is in fact limited to only a specific square meter, in a round shape, circular way, but the building that it can be built with this printer is very really fascinating, and it's originating from the Wasp. And something that is quite extraordinary, somehow remembering, for me it's like something like old times, the buildings that was built in the old on historical times. X3 is a French manufacturer of 3D printed houses founded in 2015, producing complex concrete structures. It works with ABB brand robots and develops its own software in house. In addition, the company aims to develop more mobile machines to overcome certain manufacturing limitations. The startup explains that the machine is based on technology similar to that used to deposit molten material. One of the company's most famous projects is the delivery of the first fully certified 3D printed houses in France in Reims. Thanks to the X3 3D printing technologies, it was possible to design hollow walls to integrate pipes and insulation materials. It is clear that the limitation is really dependent on the stationary of the robots, because if the robots cannot move, the area that it can cover is really limited. And one of the project that they have recently could successfully finished is in Rhyme, and it's just based on printing the walls and later just install the walls in the place on the of the construction site. They have printed 35 walls, in the dimension of 2.5 meter in 2.5 meter with the thickness of 30 centimeter.